Welcome to Study Loop.
So we have an iron boiler of 180 kilograms and water inside it of 730 kilograms. And they're initially at 18 degrees Celsius. For part A of the problem, we want to find out, given that the power generated by the boiler is 52,000 kilojoules per hour, how long will it take for the water to reach boiling temperature, which is 100 degrees Celsius? Of course, when the water reaches 100 degrees Celsius, the boiler also reaches 100 degrees Celsius. As long as you remember that, you'll be fine. So obviously, heat is mc delta T, which is in this case, for the water to reach that temperature, we have mass of water, 730 kilograms, times C for water is 4,186 joule per kilogram degrees Celsius, plus for the iron, the mass is 180 kilograms, times the specific heat of iron is 450 joules per kilogram degree Celsius times delta T, and our delta T is 100 minus 118 degrees, which is 82 degrees Celsius. Notice that our units cancel off very well, which gives us the amount of energy needed, which is, let's say this is some Q. Now, this is energy. We know that power is energy by time, which means time is energy by power. So to find the amount of time taken to produce this much energy, we simply take this energy, Q, and divide it by our power, which is 52,000 kilojoules, which is 52,000, which is 52 into 10 power 3, times kilojoules, so another 10 power 3, 52 into 10 power 6. Now by substituting this into a calculator, we can see that this comes out to, notice that the units are joule per hour, and here the units are joule. So our units will be in hours, not in minutes or seconds, RSI units. So this comes out to be almost 4.946 hours. But because we have numbers only up to 2 significant digits here, we write it as 4.9 hours. Now, for part B, we want the water to evaporate. So let's say the water is already at 100 degrees Celsius. Now, we want to supply the latent heat of vaporization so that the water will evaporate. So the amount of heat needed for vaporization is simply mass times latent heat of vaporization of water. Now, obviously, this is equal to power times time, as usual, like the last time. Energy is equal to power times time. This gives us the amount of time needed is mass times latent heat of vaporization divided by power. Our mass is 730 kilograms of water. The latent heat of vaporization of water is 22.6 into 10 power 6, 10 power 5 joule per kilogram. You can look this up in the book. Divided by our power, like we saw previously, is 52 into 10 power 6 joule per hour. Notice that our units cancel out, giving us hours. So this number is also in hours, and it turns out to be 31.727 hours. But this is the amount of time needed to boil off the water after it has reached the 100 degrees Celsius. So the total time is the amount of time needed to bring it to boil, which is 4.946, plus the amount of time needed to boil it off, which is 31.727, which turns out to be 36.673 hours, which is 37 hours.